Hi, welcome back. Next up, we will have Leo talking about accelerating Python's performance with C. Thank you, Leo. Welcome. Please give him a round of applause.
Thanks a lot. Hope you guys are not sleepy from lunch. We'll start. So my name is Leo Chen. I work for Bloomberg, and my team here is mainly in charge of data ETL pipelines for Bloomberg for some products. And my team also maintains a bunch of Python services. So today I'll be sharing some interesting experience about how to accelerate your Python. I think the title reveals a little bit, but let's pretend I didn't say anything about how. So, yeah, cool. So working with Python is great. Python is great. Since you're all in the PyCon, I assume you all agree with me. Because it's easy to use, it's dynamic typed, so there's several benefits out of it. And it's known for fast development. If you want to make a quick small service, you want to do a prototyping, you want to experience something, Python is the go-to language you usually try. And not to mention there's like a really great ecosystem, vast library support. Almost all famous platforms, not even famous, like popular platforms, databases, and services are providing Python SDKs or APIs, which you can easily use. You want a web server, there's like fast API, there's Tornado. You want to run machine learning, there's PyTorch. So it's really easy to use. I think there's also some speakers mentioned earlier today. It has one shortcoming, is that sometimes it could be slow. Why it's slow? Mainly it's also because it's dynamically typed and there's no just-in-time compiler for C Python. Someone mentioned Python 3.13 released last month already support this, but it's still like early stage where like there's definitely a long run to go, but promising. And I'll be really cautious about talking about like garbage collection routines and also GL about Python, which is kind of complex, but not necessarily make Python slow, but it could be some effect there. So in general, Python is slow when it's performing some CPU-intensive processes. My team runs into this issue where we have to process a really huge CSV byte and need to chunk it into smaller CSV chunks, keeping the header, keeping the formatting, keeping the encoding. And unluckily, Python's standard library CSV is written in C Python API. There's no extra API provided to tweak it, and CSV only accepts strings and cut it with some information loss. Well, it's not remembering all the CSV dialect while it's parsed the CSV. So the original workflow was whenever we got a string, we decode it into Python string, using CSV to parse it, lose some information, but with specific CSV rows, we combine it back, encode it in bytes, and send it over. So you can imagine this whole process is really slow, and at that point, I just close my eyes and ask Sky whether there's better ways to handle this. Well, there definitely is. So ideally, we could have something outside of Python. Just imagine an ideal situation where your Python project works. At some stage, it says, okay, this is not the task I want to take. Outsource it to other languages like C, like C++ or Rust. Do the job, and later on, when you have a result, get it back for me. So that's ideal, but luckily, there's already many ways to achieve this. And as a matter of fact, many libraries are supporting this. So some methods supports faster compilers. Some speakers talk about NumPy this morning. There's also PyPy. There's even JSON, which I don't know if it's still actively maintained, but there are ways that people make faster compilers, and there's other ways where people trying to make sure you can call other language from Python. You definitely can use the same Python API, which NumPy use, but it's kind of complex. And also there's libraries like CPypes, which is in the standard library, and also say I have CFFI, which allows you to load a dynamic directly link library from C and use it in Python. But today, what I will be introducing and what we chose is the most famous one, Cython. So what is Cython? Cython is a optimizing static compiler for both Python programming language and its extended C, Cython programming language. So Cython is, you can consider it based on Pyrex, which is a mini language, but very similar to Python with some small grammar change. And it makes writing C extension for Python really easy. And it usually have two major use cases. One is like, if you want to make your C Python interpreter faster, you can just Cythonize your code directly with it, and you gotta improve it. The use it is almost like how you use number, where number you need to add a decorator here, you just need to configure something. And also it interfaces Python code with external C libraries, which is also quite convenient, and I'll show you how to do it. So here's like a really, really basic demo where imagine you have a really complex logic in a C code where you start with writing your logic in C, so which is basically C code, and then you need some sort of a glue code in the middle, which kind of bind the C functions and interface it to Python. And later on, you just need to set up something in your setup.py, which tells your compiler how to work with Cython. And that's it. Once you compile it, once you build it with Cython, this is a library, dynamic library you can directly import with your Python projects. So my team also choose this solution while we're getting the raw CSV bytes. We rewrite the CSV parsing logic with just recognizing bytes with like a single byte encoding, multi-byte encoding, and consolidate those logics and directly work on the input bytes and output bytes. So there's no string byte encoding in the middle, which makes the process really fast. Running on Python 3.7, it's like almost 5 times faster, but it was tested a long time ago, so we didn't have the number for Python 3 now or 10 or 11. Also using Cython, there's other advantages. Someone mentioned free threading this morning. Cython have the same pace on supporting this with Python 3.13, which almost the same. And way earlier than that, Cython has its no-GIL decorator, which allow you to sometimes do some sort of JL release and reacquiring if you really know how to parallelize your function. And Cython itself supports these loop parallelism when it recognizes it and in its API, like you write with Cython prange. And also it supports C++ functions. It have like really good support on the C++ stuff like the functions operators overloading. It supports the templates. Sometimes the grammar is slightly different. Like you cannot really, there's no like asterisk operator. So it's a different one in Cython. But overall, the support is very good, and it's just ready to use libraries. So Cython do provide these libraries which you can import in your Cython script. Most of these. If you need to use. There are also other features for Cython. So there's pure Python mode. So if you think like maybe in general writing a C library is complex, I just want to apply this optimization in my Python code, it supports it. You just need to use the Cython annotation. Just to be careful, don't mix with like a Python's annotation. But if you have the Cython annotation with your normal Python functions, when you Cythonize it, it will speed it up. It will try to optimize it because it knows the exact C type. And also, sorry, there's an annotation mode which give you an optimized way to visualize like what happens in your code, where the actual Python and the C Python API or like the shift takes place, and let you know whether you should be using this or how to optimize your code. So the key takeaways here for using Cython and Python is that these helps balance the development speed and also process speed. Give you more flexibility when you know certain tasks should run outside of Python. And also, Cython should be considered when you're handling compute-intensive operations, like NumPy or those libraries already using C, which sometimes for your project this is also a good solution. There's definitely risk comes with the benefits, so you should be careful about handling the memory, also the gel release if there is any. But it definitely empowers your Python project more. And at last, the Cython is really useful and powerful. Hope you get something today to refresh your mind and try to use it yourself. And here's my contact info. If you have any further questions you want to discuss, feel free to shoot me an email and let me know. That's it. Hope you enjoy. Thank you.
So we actually have a few minutes extra here. So anyone has any questions for Leo?
So he can use with the C++ also?
Yes. So C++ code usually it's like easy, how do I say, writing the book code expose the functions you define in C++ and in Python you can directly use
I
it.
can include a C++ library?
Yes, you can also, as long as the declaration is clear. Yeah. No questions. Sorry.
Right. You got it easy. Okay, thank you very much. Thanks, Leo.